Hi, this is Dalia Tirapista, and I'll be discussing two different satellites. So, let me give you a brief introduction about satellites. A satellite is an object that moves around a larger object. Earth is a satellite because it moves around the sun. The moon is a satellite because it moves around the Earth. So, Earth and the moon are called natural satellites. There are thousands of man made satellites. Some take pictures of our planet, some take pictures of other planets, the sun, and other objects. These pictures help scientists learn about Earth, the solar system, and the universe. With satellites, TV signals and phone calls can be sent up to a satellite. The satellite can then send them back down to different spots on Earth. So, my first satellite is Jason 3. Jason 3 is an active low Earth orbit satellite. So, what is Jason 3? Jason 3 is a satellite altimeter created by a partnership of the European Organization for the Exploitation of Meteorological Satellites and National Aeronautic and Space Administration, and is an international cooperative mission in which National Oceanic and Atmospheric Administration is partnering with CNES, which is a French space agency. It also follows the current operational altimeter satellite Jason 2 in maintaining satellite altimetry observations of global sea surface height. JSON 3 will make highly detailed measurements of sea surface height, which is a measure used to study sea level rise, a critical factor in understanding Earth's dynamic climate. Sea surface height data from altimetry satellites like JSON 3 are also used to study hurricane intensity, tsunami dynamics, El Nino southern oscillation, eddy dynamics, ocean boundary currents, coastal and shallow water tides, as well as weather and climate forecasting. JSON 3's mission objectives are continue and extend the long-term sea level monitoring initiated by the previous JSON missions and support scientific, commercial, and practical applications related to sea level rise, ocean circulation, and climate change, mostly oceanography mission. For its orbit details, to ensure continuity of the global sea level record, JSON 3 will fly in the same 9.9-day repeat track orbit as all previous JSON missions, meaning the satellite will make observations over the same ocean point once every 9.9 days. So for the orbit type, it's a Sun synchronous orbit or SSO. Inclination is 66.05 degrees. Orbital period is 112 minutes per revolution around the Earth. Apogee is 1,380 kilometers and perigee is 1,328 kilometers. For launch details, launch date was January 17, 2016, and the launch provider was SpaceX using a Falcon 9 rocket from Vandenberg Air Force Base in California. For the payload details, JSON 3 is equipped with a suite of advanced instruments for Earth's observation, primarily focused on measuring sea surface height. The key payload components include Poseidon 3B radar altimeter, which measures the distance between the satellite and the ocean surface, providing critical data on sea level changes. There's JSON 3 radiometer, a microwave radiometer that measures atmospheric water vapor to correct altimeter readings for atmospheric effects. There's GPS or Global Positioning System receiver, provides precise positioning information to prove altimeter accuracy. And there's instrument suite, various additional sensors for atmospheric and oceanographic data collection. And the bus details for the power system, solar panels for energy generation supplemented by batteries for operation during eclipse periods, and it has a 550 watts. For communication, high data rate downlink capabilities for transmitting collected data to ground stations, along with S-band communication for telemetry. Altitude control system ensures that satellite maintains the correct orientation for accurate data collection. And the platform is based on the heritage of the JSON series satellites. The launch mass is 553 kilos or 1,019 pounds, and the dry mass is 525 kilograms or 1,157 pounds. And its dimensions are 3.8 by 10 by 2 meters. So let's go to another satellite. Next is the Diwata 1. Diwata 1 is a decommissioned low Earth orbit satellite. Decommissioned means it is not an active satellite anymore. Okay, so what is Diwata 1? Diwata 1, also known as the Phil Microsat 1, was a Philippine microsatellite launched to the International Space Station on March 23, 2016, and was deployed into orbit from the ISS on April 27, 2016. It was the first Philippine microsatellite and the first satellite built and designed by Filipinos. It was followed by Diwata 2, launched in 2018. Diwata 1 was the first satellite of the venture made possible through the Philippine Scientific Earth Observation Microsatellite, or Field Microsat program, a 3-year program funded by the Department of Science and Technology. The program is a collaboration between the University of the Philippines, the DOST Advanced Science and Technology Institute, and Japan's Tohoku University and Hokkaido University. It was initiated in December 2014 by DOST. The satellite was an updated version of the Raijin 2, which was developed by the two Japanese universities. Diwata 1's mission objectives are to provide imagery and data for various applications, including disaster response, environmental monitoring, and agricultural management, and to enhance the capabilities of the Philippines in space technology and Earth observation. The orbit details are: orbit type is Sun Synchronous Orbit or SSO. Orbit altitude is approximately 600 kilometers. The inclination is about 97.9 degrees, and the orbital period is approximately 98 minutes. For the payload details, there is multispectral imager. It captures images in multiple spectral bands for various applications, including agriculture and disaster monitoring. There's high resolution camera that provides detailed images of the Earth's surface for land use and urban planning. There is UV vis spectrometer, and it measures atmospheric conditions and provides data related to air quality and pollution. There is data storage and transmission system for storing and relaying the collected data to ground stations. For the bus details, the platform is based on a microsatellite design. Mass is approximately 60 kilograms. Dimensions roughly zero point 0.6 by zero point 0.6 by zero point 0.6 meter. Power is solar panels for power generation designed for operation in low Earth orbit. Communication utilizes radio communication for data downlink and telemetry. And for altitude control system, stabilizes the satellite for accurate imaging and data collection. So thanks for watching. Have a nice day.